got the session. Hmm. So today only I will take the class. As Pratyush is ill, he will not able to explain the things properly. So he might be available in the chat box, but he will not take your classes as he is ill. So let's start with the part that we had not able to debug in the last coding session of inheritance and uh, operator overloading, and also we will cover uh, this one polymorphism. So the class would be around 1 hour. Let's see how it will go. So I would request all of you to try to replicate the code that I will do, so that you will also learn side by side. uh, and I think the learning would be great if you just try to implement the things as soon as possible. So whatever error that will come in your screen, you will share, uh, then we are going to respond to that error, so that learning process would be more helpful as compared to the case when you do it separately after the classes, right? We will go slowly so that you can understand all the concepts that are related to operator overloading and this inheritance and polymorphism. So let's start now. So I hope the screen is visible to all of you. The screen is visible, right? So this zip file I have shared in the last coding session. I will try to start from that zip file only. I will just copy it and paste it here and extract here. So these are the things that we had done earlier. So classes we are able to successfully do completed that day. So I am deleting this particular folder related to class. So let's start with the inheritance part. So I will again run the same command wclean wmake. So this was the error that we are getting in the last class, right? So first of all, we should understand what is the cause of error. So it is saying that expected unqualified id before public. So let's go inside. So we need to understand that we are trying to understand the concept of inheritance, and inheritance means we are trying to uh, inherit some of the properties from the base class. So when we do it, we need to have certain kind of definition. So earlier what we had done is we have only defined the derived class, but we haven't defined uh, from where we are trying to inherit the properties. So we need to define uh, the base class here. For that, we have to just put double colon here, and then we have to write we are trying to uh, we always try to access using public mode, and then we need to define the name of the base class. So here again also again here in the Reynolds number also we need to define it like this. So if I save it and run it, let's see what will happen. So so there is some error, that is it is showing that expected this sign. So let's go inside. See here I haven't provided this curly brace, so I have to provide it. Now it has compiled successfully. You know what was the error? The error was in defining the derived class. So whenever we try to define the derived class, we have to define it using the public mode, and we have to uh, write the name of this base class, and the base class is this one, flow in pipe. So we have missed this particular part uh, in the last coding session. So we have to define this particular uh, uh, this base class name. Now we are trying to calculate the pressure drop. So let's check the value. For that we have to type the name of the solver. If I just type inheritance, that is the name of the solver, it will give us the pressure drop through a pipe 1, that is 0.08. But we are also trying to calculate this one, also the Reynolds number. So in order to calculate the Reynolds number, uh, so when we try to again we want to calculate the Reynolds number, so we have to use different object in order to calculate the Reynolds number, because we have different class for calculation of Reynolds number. So we have class for derived class for calculation of pressure drop, that is calc pressure drop. Similarly, we have separate class for this calculation of Reynolds number. So we need to call it using this calculate Reynolds numbers. For this we copy this uh, class and then try to create another object for this. So we have to create object, this is pipe 1 only, we will call it as A, because we can't have same object name for different classes. So we have one class, derived class. For this we have defined object as pipe 1. Similarly, for different class, we need, for different class this calc re, we need to define a different object name. So now we have to change this pipe 1 to pipe 1a, and we have defined the row, because in order to calculate the pressure drop we need these three constant values. Constant value means mu, this scalar, this flow rate, viscosity, and diameter. And from this, and again we have separately calculated we have a separate function for length. So using these four parameters we can calculate the pressure drop, and we have called this uh, pressure drop function using the object pipe 1. Similarly, in order to calculate the Reynolds number, which require different uh, input parameter, and that different input parameter is rho. So rho was not required in the pressure drop calculation, only length was required. Here length is not required, rho is required. So rho is separately defined. So now the Reynolds number for pipe 1 is now it will be a different object name, that is pipe 1a. Now if we save it and run it,
Nikhil, please zoom it more.
okay. So it is giving nan values. That zoom option is not coming now. I need to, I think zoom option is not coming here in this screen when I go inside this .c file. So now what error it is showing now? Again I have to run it. It is showing nan. Why it is showing nan? First of all, we need to understand it. So if we go inside the definition of this Reynolds number, huh, uh, see again we need to, so why it is giving us nan value? Because for in order to calculate Reynolds number, we also need these values of flow rate, this flow rate, diameter and mu. So for this object pipe 1a, we haven't defined this input value. So we have to define this input value, and we need to change the object. The object is pipe 1a. So I am copying it and pasting it here. So now for calculation of Reynolds number, which has object of pipe 1a, has input values of this one, q, mu and diameter, which is same as that of pipe 1 for calculation of pressure drop. So if I just run it again, see it is now showing the value of Reynolds number, which is coming out to be 100. So this is how we need to do the inheritance. So I hope the things are clear now, because in the last class we were not able to debug the code properly because we have missed some of the definition of uh, derived classes, how the derived classes are defined. Now I hope that it is clear that how to define this derived class. So the inheritance concept is now completed. Let's move on to operator. So again, I have extracted the file and we will try to run the same code again and we'll see what error was coming.
Nikhil, read the chat.
Please drop the inheritance.c in the chat box. I am still getting error. So can you tell me what is the error? Or you can share your screenshot in the chat box. That will be much better of the error what you are getting. Because at the end of this session, we are going to share all the three files that is related to operator overloading, inheritance, and polymorphism. So no need to worry, because at the end we are going to share all the files with you all. If you want to rectify, just you can share the this screenshot of the error that you are getting. Pratyush and I will try to debug it for now for you. So it is saying L was not declared in this scope input row. So probably you have defined L somewhere else. You need to check it in the code. So from this one, I would like to explain the things. Uh, hmm. So L we have to define inside this pressure calculation of pressure drop. Probably you might have not defined here. You might have defined somewhere else, because in order to calculate the pressure drop we need L, and L should be defined here. And one possible cause of error will be like this one. So you have to input the value of L, and it should uh, so what is the data type of this one, length, whether it is defined scalar or vector, scalar or label. So if you have defined scalar, it's better write 1000.0. So I think this might be clear once you try to go through the code again. So I am going to start this operator overloading. So this was the error we were getting in the last class, and we were not able to resolve at that time. So the problem of error was that we are trying to first create object, and we are specifying the value uh, to the constructor. So but we haven't defined any constructor function here. That is the cause of error. So first, so we need to uh, first define the constructor function. So the constructor function will be this one, scalar, the name of the class here, and then how we are going to define the values. So it is scalar a and scalar b, because in the last class we are trying to call this constructor function, but constructor function was not defined. So if the function is not defined, then how it will take the values? So for that we need to define the constructor function. So the constructor function is defined now, and that constructor function value is here, that is complex number, that is real part will be equivalent to a and imaginary part is equal to b. So now that 3.25 will come here, and the value of a becomes 3.25 when it this function it when it goes inside this function definition. This a value is assigned to this real part, and this b value is assigned to imaginary part. So this was the cause of error. Let's try to run. Hmm. Again it is showing some error. No matching function to call complex number. So here we are trying to change uh, change the definition of how we are trying to perform the uh, operation. So let's change it to, so here we are directly, because this, because the earlier definition was valid only for null constructor. We are not providing null constructor here, we are providing a constructor with argument. So so it is showing some different error now. I think semicolon is required here. Now it has run properly. So that was, so in the last class we haven't defined what is the constructor function. We haven't defined how it will going to take that value. So now when I run this solver, the name of the solver name, that is operator, we see that these two numbers are added, which is equivalent to 3.25 and 5.11, which will equivalent to 8.36, and this summation is equivalent to 3.64. So this is how we perform the operator overloading. So why we are calling it operator loading overloading is because first we are providing this number, right? So this compiler will go here, then as soon as it sees this operator, it will not be able to perform the calculation. So the second uh, that second through the second object, the values of real parts and imaginary part are called, and it is now operated. So the first complex number is this one, 3.25 and 2.44, and the second complex number is this one, 5.11 and 5.11 and 1.2, and we are trying to operate by addition operator. So if we want to multiply, we can use multiplication, division, things like that. It depends upon what kind of operations we are trying to perform, right? So this is how we do the operator overloading. You see, both are same number. I mean, both are complex number, both have imaginary part and real part, but we are trying to add it, and one has so the real parts can only be added to real part cannot be added to imaginary part. So that is why the concept of operator overloading comes. Now let's say this is how we uh, define uh, the operator overloading by providing two separate value. Let's say we don't want to uh, provide value for the second complex number. Let's say we have by default value. So when we have by default value, then we don't need to define value here, right? So if I directly run it, it will throw an error, because if we want to add two number and the second number is not provided, and we are saying that it should take value from the default value. So first of all we need to define what is that default value. So in order to define the default value, we use the definition of a default constructor, that is a null constructor. So here we don't need to specify any value here. We can directly specify value as 5.11 and 1.2. So but here again we are not calling that function. So in order to call that function, I need to write simply this line. So this is the null constructor. So whenever we don't provide any value here, we are not providing any value here, so it will call this null constructor, and when this null constructor is called, it will go inside this definition. So automatically the by default value will be 5.11 and 1.2. But when we call using this definition, then it will call constructor with its definition. So if you look at the definition 3.25 and 2.44, it will go here, it will not go here, it will go here and will uh, take the value and perform the summation. So let's again run this one. So it has again now shown the same results, but you see how I have defined the values of real part and imaginary part. Initially I have defined using this uh, with the constructor definition itself from the objects. I am directly calling that constructor function. But in the second case, I have changed the number to object definition. So here only the null constructor, that is the default constructor, is called. Let's say I am defining this value here. Let's say we are changing the number again. Let's say this is number 1 and this is normal. So let's see what is the answer. So 10.22 and 4 2.4, meaning whatever number we are providing from here, that is 5.11, and by default value is also 5.11. So both gets added, and similarly for the imaginary part 1.2 and 1.2, which is equivalent to 2.4i. So I think this concept is clear to all of you. And let's say we don't define number 2 as well. So how it will perform? It will again call the same null constructor. So again the answer will be 10.22 and 2.4, because both the object will call this a null definition of the constructor, which is equivalent to 5.11 and 1.2. So these things are common. This I think in the classes also we have learned this concept, I mean how to define these things. And we have also learned these things, how to define how to call the objects from the main function. And we have also learned about this definition of the main class. So the in the operator overloading, the new concept is this thing, how to define the function related to operator overloading. So this is the keyword operator and the operator name and the operator symbol, and the definition of uh, this operator overloading. So this definition you need to follow it. It is to be noted that we have double colon here, but we don't have double colon here. We have double colon before the operator. So this is how it is defined uh, in case of operator overloading. I hope the concept is clear because I have taken few permutation and combination of the numbers. I think now you will be able to understand the concepts related to operator overloading. I hope it's clear to all of you. So anyone having doubt in understanding the inheritance and operator overloading? You can type in the chat box. Are you all there or you have just left? Yeah, only two has replied in the chat box. That complex number is nothing but we are calling by a reference. So how we are going to take the second number? So there is a difference between call by reference. Call by reference means whatever number we are taking as an input, uh, it will try to perform the operations instantly. I mean without changing the value. So like let's say, so here with this function definition, it should be any variable name. Like you can change it to, let's say, random. I mean you can take anything like r. So if you take 4r, then whatever the value will come, it will directly try to operate. Sometimes what happens, like C++ has different way of operating the things. Like uh, it might not change the value instantly in the same time step. It will try to change the value in next time step. That's why when we provide this and symbols, that means we are trying to call this value by reference. That means the changes gets reflected instantly, I mean in that time step only. Or we can change this so this num2 I have initially defined. So it is not a strict rule to define that num2 because it may create confusion. This num2 is here and this num2 was there also, so we can change the num2 to some different variable name like here. So you have to replace here also. So you can just write any variable name when you perform the operator overloading inside the function. So this can be different also. So similarly here also we can use some different name. So this definition, I mean how we define the things inside this is temporary. These things are temporary. It should not be like num2 should be here also. It is not necessary. This the function definition. I mean the how we are going to perform the addition should be temporary. Should be contained inside a temporary variable. And when it returns, it will return the exact value. I mean whatever the calculation it will perform, it will return back here num1 plus num2. So that significance of and is it is we are calling it by reference at that and that values uh, is directly implemented. Now let's move on to polymorphism. So let's create another solver. So when we perform polymorphism, first of all we need to understand what is the meaning of polymorphism. Poly means many and morphism means it exists in, I mean different forms. Like poly means polymorphism means something that has more than one form. For example, uh, you can be uh, a brother to your sister, you can be uh, a son to your father. Similarly, you can be uh, a student to your teacher. So you are one, but your responsibilities are different, right? So in C++, we in object-oriented programming of C++, we have a concept of this polymorphism, meaning we can define a function, but whatever the function definition we have defined and whatever the value we are providing, uh, that function should be able to perform the operation based upon our input. So we will going to understand it more clearly when we are going to code it. So let's copy the inheritance part. So I'm just copying the inheritance.
Excuse me,
Yeah,
your screen is not shared.
is it not shared? It is shared. For how long time you were not able to see the screen?
About 5 minutes. You
Okay,
can stop share
okay, okay.
and share it again.
Is it visible now? Let me try to fix it. Could you please wait for a minute? You can just revise or you can just code that part that I have explained just now. I think it's now visible. So let's try to copy the content from this one. So we have copied the inheritance coding uh, in order to understand uh, the concept of polymorphism. So polymorphism, it is of two types. What are two types? That compile time polymorphism and runtime polymorphism. So in compile time polymorphism, we have function overloading and operator overloading. And there is another type that is called runtime polymorphism, that we deal using a virtual keyword. So we will understand it more clearly when we are when we are going to code it now. So let's ignore this calculation of Reynolds number for now. Now what we are doing here is we are trying to understand the concept of this polymorphism. So let's assume this is the, let's say this flowing pipe is the base class, and this base class has one input function that takes input of three variables. Let's try to define that variable differently. Let's say we have a function input value which is taking two arguments of scalar type. Let's say we are defining the same function which are taking values which has label data type. And let's say we have a function which we are not provide which in which we are not providing any argument. So you can see uh, we have a single function and name of the function is input value, but each of the function is taking different arguments, and one of the function is not taking any argument. So this is what the meaning of polymorphism is: one function with different kind of characteristics. So let's try to check the values. Let's say we are trying to see the values. So let's define a display function. So we want to see what is the difference in calling those three functions. So in order to see what is the changes, if we are calling this different function, what values it will going to show us. So for that, I am creating a display function which will display the values of this one and this one, that is in the first argument, second argument and the third argument. So so the value of, so what is the value of first scalar? So if you go into the definition of input value, where is the definition of input value? Huh. This is input value definition. First is mu, second is diameter, and third is u, velocity. So the value of diameter is, and the value of, what is the third quantity? Velocity. So these are the display function for this mu, diameter and u. Now we are going to uh, create a object for this flow in a pipe. So let's create an object. Flow in a pipe. Let the name of this object is f1. Now if we call f1 dot input value, and we need to provide certain value here. Let's say we are providing 2.2, 5.333, and let's say 0.0222. So this is how we have defined, we are calling the input value function by providing these three values as argument to that function. Let's try to display it using again f1 dot display. Let's try to run it. So now it is showing us certain value, and the value is this. So we are providing these three values: 1.2, 5.3, 4 times 3, and then 0.03 times 2. So we are getting this value. Now if we change this value, let's say we are changing this value to 1, let's say 5, and let's say 2. So what it will show us now? Some error is coming. Wait. Undefined reference to pipe input value. So it is throwing some error. What is the error? Flow in pipe input value int 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 int. So let's try to change it to this one to int, because it is saying we are providing int, and probably that label data type is not exactly taking in the form that we are providing. Again we are getting the same error. Yeah, it's good that we are getting this error, because we need to understand that why this error is coming. So let's change it to label only, or we can use int as well. This error is coming because we haven't defined the definition how we are going to take this input value which is of label data type. So again we need to define here, copy it, paste it. So here we need to change it as label, because we haven't defined what is the function definition when we call that input value function when our argument is of label type. Now let's see how the results are. Now it has run. So now you can see earlier the value was different and now this value is different. We are calling the same function but with a different data type. Still it is showing us some value. But when I had not defined this separate definition, this definition, so it was showing error, right? So if this particular definition was not defined, then it can only accept scalar values. But since now I have defined the same function with argument as label data type, now it can accept values of 1, 5 and 2. Earlier it can't accept these values because earlier the data type was scalar. So from the same input function we can try to have a different value of mu, u and diameter, or it can be written in another way like this. We need to change the object. We can't use same object. So you can see the same function is giving us two different kind of values. One is scalar value and one is integer value. So this is what the meaning of compile time polymorphism. The same input function has can be called using uh, different kind of values with different data type. Similarly, we can also provide the third way. that is not providing any argument, so that it will take any value 1, 2.2, 2.5, sorry, then 0, 0.0, 0.25. So now if we are not providing any value here, so let's see what value it will show now. So now you can see the three values here. It's purely label value, it's purely scalar value, and this is our by default value, whatever value we have provided in this definition. So this is what the meaning of compile time polymorphism is. Now uh, in order to understand a runtime polymorphism, uh, let's try to call the same function from uh, a derived class. So this display function we are calling in the flow in pipe, that is base class. Now let's try to call the same display function in this derived class. So the value of viscosity, let's say we can define the value of length as well. So now let's try to understand this runtime polymorphism. For that we need to close this thing. Let's say using the base class, let's say we want to create a pointer. I think the concept of pointer is quite clear to you. Pointer is a variable that holds the memory address of the defined variable or another variable. So that is defined using star. Let's the name of the pointer is f1. Let's say we create a object of this derived class. The derived class is this one. The object of derived class is p1. Now what is pointer? By definition we know that pointer is a variable that holds the address. So f1 should hold the address of p1 object. So now if I call this function, what is the name of the function? Display function. So we have to write it like this. So from this definition it's quite clear that we are going to uh, uh, from this definition it's quite clear that this f1 is a variable that is holding the address of p1, right? So when it is holding the address of p1, then whatever we call through f1, it should give us the result related to p1. So let's see. First of all, let's call uh, this p1. So using the object I am calling. So input value, let's say, so I am providing certain input value to this derived class. What is the derived class? This one, calc pressure drop P1, and that is the object of this derived class. In the P1 I am providing certain input values. So this is how we are providing the input value, and we have length as well. So what is length function? Input length. Let's say the length is 3.2 meter. Now if we try to uh, display all the values using this pointer, that is F1, see what value we are getting here. We are getting the values. So we are trying to display a function. So first of all, I would like to again explain the code. So this is the main function. In the main function, we are using the base class, and we have created a pointer using the base class, and we have a derived class, and we have created an object of this derived class, that is P1. So as we know that this is a pointer, and we have defined is using star. So pointer is a variable that holds the address of P1. So address of P1 means uh, that F1 has the address of object P1, means whatever is inside the P1, that is P1 is nothing but this calc pressure drop. See this calc pressure drop, it should have the information of this calc pressure drop through object P1, right? So I have provided the values of input values and the input length, and I am trying to display using F1. We are calling this display function using the pointer F1, and the pointer F1 has only information of, so it should call this display function. So but when we run the simulation, we find that it is not calling this input, this display function. It is calling this input, this display function. So this is what the meaning of polymorphism is. So in order to call exactly this function, we need to use virtual keyword here. If we use virtual keyword here and save it and try to run the uh, solver again, so these are nothing but warnings. You can ignore the warning, it is not an error. So now you see that now it is calling the same function, this display function from the calc pressure drop, and we initially wanted to call the same display function from the calc pressure drop, but since we have two display function, so by default it is taking the display function which is defined in the base class, but we wanted to display this function. So in order to do this, because uh, uh, the function has same name in both base class and derived class. We need to define a virtual keyword here, so that it will uh, not access the information from the base class. It will access the information from the derived class, which is our aim, because this is what we wanted when we have defined the address of p1 in a pointer f1. I hope the concept is clear to all of you. So this is related to runtime polymorphism, and initially I have explained about this. This one, this is nothing but this is compile time polymorphism. I hope the concept is clear to all of you. So we are going very slowly. I have tried to explain many things using the same part of the code, in inheritance, in operator overloading, and here also in polymorphism. I think now you are able to understand uh, the meaning of the keyword virtual void. What do you mean by scalar label, and how these things are defined separately, and how we can define the same thing inside the class only. I think we have tried to come up with different ways of declaring and defining the functions, and I hope that these things are clear to all of you. Would you please output? So output is here, like, so initially when I have not defined this virtual, when I had not defined this virtual, the output was this one, viscosity 1.222, 5.222, and 2.22. But when as soon as I defined this virtual, it is not calling this display function, it is calling this display function. So which has length also. So length initially was not there. I hope the things are clear to all of you. So this is the end of today's session. Okay, we will going to clear this. So Rupak, can you also refer to the original OpenFOAM code? We will going to show you more things, because there are more things to learn, like dictionary and object registry. When you understand all the things, then we are going to show all of them in one class, because it will take a lot of time to cover the other parts as well. So at that time only we were going to explain all the things in the more complex C++ code. What are the application of operator overloading? As we know that in CFD we deal with various types of quantities, like scalar quantities, vector quantities. Like the pressure is a scalar quantity, so the two pressure values can be directly added. But if you talk about the vector, you can't simply add. Let's say we have two vector, that is three velocity vector, 3i plus 5 3i plus 5j. That means three magnitude of velocity in x direction, and 5 velocity of velocity in the y direction. Similarly, uh, we have another velocity value at certain grid points. So the grid points value of the velocities cannot be added directly, right? So x component should be added only to the x component of another velocity. Can can we use int in place of? Yes, you can use int data type in place of label data type. Yes, so you are yes. So yeah, I have stored. So the derived class object is stored on the base class pointer. So the address of derived class object is stored inside the base class pointer. So what is stored will be called, right? But initially it was not calling that display function. It is calling the display function of the base class only. It should call the base function of the derived class. You can define plus operator to add strings. Strings, how could you operate the strings? My first question is like, strings are like, you can operate on number, right? You can the plus minus multiplication division is called an operator, and you can use this operator to operate on two numbers which can have no, I mean we can use, I mean how could you add the strings? First of all, I haven't gone through that kind of uh, code in C++ to add the string. Maybe I will try to search about this operator overloading to add string. As far as I know, this operator overloading is related to the plus minus and multiplication. I mean all the possible ways of operation which we perform in mathematics. Okay, we will try to look into this concept of operator overloading to add string. As far as I know, we can only operate on the number part. So the main function is here. In the main function, uh, we have a base class flow in pipe, and we have defined a pointer, and then we have a derived class, and we have an object. Now we are storing the address of the object p1 in a pointer of the base class. Now we are calling the display function from the pointer of base class, which should have the information of uh, derived class. So it should show us the derived class uh, display function. I mean what is defined inside that display function. I hope the things are clear to all of you. If you have more doubts, so for me to access the base class function, I should write. So the base class function was by default it is taking the function by default it is calling the base class function only, right? Initially when we have not defined the virtual, So if you want to use the base class function, you can just remove the virtual. No, we only, so are we for calling derived class? No, in order to call the derived class, we use only one semicolon. Two semicolon are not required. I mean, two semicolon are not used in order to call the derived class. Only one semicolon. But when we are defining the functions uh, outside of the class, then we need to use double colon, two double colons. But when we are defining the derived class, we use only one double colon. In a scenario where there are derived class object, yet I want to access the base class object. So you can create the base class object as well. You can directly, there are various ways to call the I mean the functions. You can call it like this, like that you are that the way you are suggesting. But in case the same function is getting called, then the concept, this is what the meaning of polymorphism. I mean, you can separately call the functions as per your wish, but if the function has same name, then it is important to understand which I mean which functions you are trying to call. Okay, I think if you don't have I think the coding part is clear, although you have other kind of doubts, I can understand. I think whatever I have taught today, I think that part is clear to all of you, right? From coding aspect, because in the last session we were not able to debug few parts of the code. I think why we were not able to debug that part of code, I think that part is clear to all of you. Is that clear? Yeah. So I think we are done with today's session. As Pratyush is ill, he is not able to teach properly, so he has taken a rest. Uh, Otherwise, he would have taught you this object registries and dictionaries. So this part will be taught in the coming sessions. We will let you know when will be our next session. As usual, we have our sessions on Fridays and Saturdays, but if some extra classes are needed, then we will going to inform you when that extra classes will be going to help. Yeah, I will upload the files. Okay, so I will upload the files, and I hope that you guys have understood all the concepts. And I would like to request all of you to just try to do the same thing without referring to the code. Just try to create the function overloading concept, and just try to code whatever you have understood through the coding classes. And if you got some problem, you can recheck with the uploaded files. So I will upload the files, and I think uh, you can leave. Thank you for your attention.